Almost there. Well, this Apple thing is like in every time you open a Twitch chat, huh? Okay, that's neat. How long that's gonna last? Don't show again. I guess I could click don't show again. Suppose that's on me. Maybe. I didn't click don't show again. Okay, here we go. All right. Good morning to anybody watching. Welcome. For anybody that might be new, first of all, welcome and thanks for checking it out. My name is Tim. I go by Foamy Guy on GitHub and Discord. And on this stream, which I do typically around this time every week, 10 a.m. Central Time, here on Twitch and YouTube, I work on CircuitPython related stuff. If you are new, then you may not know what CircuitPython is. You can learn more about it here at circuitpython.org. Basically, this is a version of Python that can run on tiny computers called microcontrollers. And then if you choose to use CircuitPython on these devices, which is just one of the many ways that you can program these devices, there are lots of other ways as well. If you use CircuitPython, when you run it on these devices, typically you plug it into your computer and then it will show up like a thumb drive. You can edit some Python code files on that thumb drive, and then when you save it, the computer that is inside the chip here will actually reset and then interpret and execute that Python code that you've saved into the file. That's kind of the 50,000-foot view of what CircuitPython is and what it does. These microcontroller devices come in all different shapes and sizes and purposes. Some of them are very general with just I/O pins that you can hook up to other stuff. Some of them are more specific with built-in peripherals like screens. Some of them are made to be like a little gaming handheld, which is what I have a couple of here actually today, PyGamer, and then we also have, Pico System, which is another little handheld game thing that I have here that I was working on. So there's lots of different form factors and shapes and sizes of these microcontroller devices. There are currently 525 of them that can run CircuitPython, with more being added all the time. Huge thanks, as always, to Adafruit, which is not in my little remembery thing there for this browser. Adafruit is a hardware and software company based out of New York. They are the ones who primarily support CircuitPython by paying the team of folks who work on it. There's a team of developers who work on CircuitPython full-time and are paid by Adafruit to do so, and there are some folks like me who work on it part-time and are paid by Adafruit to do so. So huge thanks, as always, to them. And if you want to help support CircuitPython and Adafruit, one of the easiest ways to do it is just purchase hardware from their website over at adafruit.com. They have the microcontroller devices, like a bunch of the ones we were talking about over on the previous page are Adafruit devices. They also have all sorts of accessories, peripherals, things that you can hook up to your microcontroller to do other stuff with. In the case of the microcontrollers that I am using today, the PyGamer was designed and manufactured by Adafruit. The Pymoroni Pico system is a third-party one made by Pymoroni, but they were at one point in stock on the Adafruit site, and they use an RP2040, which supports CircuitPython as well, so we can use CircuitPython on that. And then jumping into where I am at today is kind of geometry land. So let me pull up the camera here. I have been working on some stuff here to make, oops, that's not the joystick, to make intersection logic for vector I/O shapes. So right now I have it set up with this test thing with these two circles, and I can drive the small one around with the joypad, and I can, it's changing colors whenever it intersects with the big one. This is currently, I think, using my actual PR from CircuitPython. I should have loaded this up earlier. 1 second here. Let's get the right thing open. Okay. Yeah, okay, yeah, that's on the device. So yeah, right now it is using the one which I have added to the core in a PR, which currently in that PR, it supports rectangle and circle. What I want to work on today is probably going to be on the Python layer, not in the core. And I'm going to try to implement Polygon intersection logic. I think will be a bit trickier than the ones that I have so far, which are circle and rectangle, which were both fairly easy. Luckily, though, I will say I have found a really great resource. Let me pull that up as well, actually. So actually, there's a whole table of contents here. Super handy, this whole website. JeffreyThompson.org. I owe a big hug report to Jeffrey Thompson, or JeffreyThompson.org at least, for their kind of like helper material about these geometric intersections. I did use the circle one and the circle rectangle one, and then adapted them to work the other way around as well. And also rectangle as well. That one's a lot easier. I was pretty familiar with the concepts of that one. We want to do Polygon. I guess I'm just going to start with probably Polygon. My instinct was to start with Polygon circle, but maybe rectangle would actually be easier. Looks like they accidentally left circle in the comments. Okay, so one thing that is important to the way these are implemented in this helper page is they build on prior stuff. So a lot of these are factored into other functions. So Polygon rect, that's the outermost thing. That's what we're kind of interested in from a high level. It takes vertices for the polygon. It takes the rectangle XY, the rectangle width height. Gonna loop through vertices. And then we're calling line rect, which is another collision function. It does use the words collision here, which I've changed it over to intersect because I think it makes more sense, at least in the way that it's implemented in the CircuitPython one. Thanks to Dan as well for that idea, actually, which is who suggested intersects. I think, I don't know. So at some point, it's worth considering in the core, do we want to have these all factored into help? Like, if we want intersection functions at all in the core, do we want them all factored in? Or do we want kind of a big implementation that kind of includes the others? Different ways it could work. But the polygon basically comes down to checking a bunch of lines, right? Checking every line in the polygon against the rectangle And then if you need to, you can also check and see if the rectangle is actually inside the polygon, which it mentions here is more intensive. So you should leave it out if you don't need it. So I'm thinking that means maybe we provide a Boolean that says, like, do that part or not, and then that way the end user, whoever's calling this function, can decide if they care about that case. If your polygon is small enough, then it doesn't matter. And if you're making a game where mostly you care about the edges intersecting, and then you're gonna, like, you know, stop movement or change directions or something as a result of that, then you also may not care if the rectangle is fully contained. And then when you get inside line rect here, we have a further set of factored down calls to line, which then is the root mathematics for this one. We have a line intersection function, which gets called by a line and rectangle intersection function. Like 2 lines, basically. You know, you give it 2 lines, you find out if they intersect. Then that's used within the rect one, which goes on to get used within the polyrect one. Another thing I found was this one, which is kind of an interesting one. This is, I believe, pure Python. Theoretically might work on CircuitPython. Let's actually see if it does. I'm going to rename it to that so that I have a better idea of what's in it before I open it, when I inevitably don't remember. So high level, does this, like, explode if I import it? Numbers. Deal. It actually looks like it's only used for typing to my eye. So we could do the same thing that we typically do on CircuitPython, except this, that would go inside there, and then this would just keep going because we don't actually need that stuff for the implementation. Ooh, infinity, we probably, I don't know if we have a representation of that, maybe in ULab somewhere. Okay, well, the short answer is definitely doesn't just work. 17? inside of reset. Oh. Well, this is a math thing. Interesting. Do we have, what all do we have on math? We have is, infinity, and finite. How do we have is Is that not what that means? Should have done math off them. Return true if x is finite. Return true if x is infinite. How could you represent infinite with a float? Or I guess another way to phrase that question is, what can I pass to this to make it true? Okay. That's interesting. Huh. Okay. So then why is there also a math.infinity? Anyway, it doesn't matter. We could probably change this. Well, maybe it matters. He says doesn't matter as he doesn't actually know. I mean, this is gonna just get printed out, it looks like, right? I don't know. Seems fine. Maybe we should try one more thing, actually. Should copy this. Oh, okay, let me do it this way. Search. Is this used anywhere else? It is. Okay, util, midpoint, max point. Let's fix those two. But nothing, you know, there's nothing that's like testing against that, right? There's no code that says if infinity do this or something, seemingly. So, I don't know. I don't know if they're actually like mathematically important in this. Let's make sure the negative one works. Okay. Type error. Yeah. I don't really know what that's trying to do. Kind of weird that it doesn't I mean, that's going through the tests. Do I really need the tests? Hey, okay, that actually ran and finished. I mean, for all I know, there's a test that says pass it the wrong thing. Although it doesn't look like it. So this is using Pygame. Test concave polygons. This one basically has just circles and polygons, but you could use the polygon obviously to make a rectangle. So let's see if I can re-implement the test I have using this and then change it to a polygon and see if it works with a polygon as well. Basically, I'm trying to wrap my head around the math involved in the polygon collision detection or intersection. So we're going to draw the vector IO stuff, but instead of this should just let me drive the small circle around. Let's make sure that still works. Yeah, it won't change colors anymore because there's no code in the intersection right now. So then what we want to do is try the new way. So should I create new circles or try to reuse a circle? The one thing that's odd, I mean, it's not really odd, it's just different about the way this one works is the way I was doing it, it's actually, I implemented it on vector IO, circle, and rectangle. So in this code, it was just calling circle dot intersects, and then you could pass the other circle or you could pass a rectangle as well. Now we're going to be separate. Our geometry won't be tied to the actual visual in this implementation of this. Polygon math is never fun. Mostly, most game dev I did was all in Unity, so I didn't have to think. Yeah, it is. It definitely makes you appreciate things like Box 2D and other implementations of all of this stuff that just kind of like work and you don't have to question about how. Simple circle. So one thing, I guess we can check. Can I just change the, I mean, they're just properties, so I could always just update them and yeah. So position is a vector, I guess. Okay, so when we create, let's say, static circle, let's go and also make a static circle vec Actually, we'll import it as star, so we can just do vector. That wants an XY, so that's the same as this one. So I will just access them instead of duplicating the hard-coded value. And then from that, we can make static circle geo for geometry. It's not the best, but whatever. Oh, we do have this problem, though, is we now have 2 circles, don't we? But we do have vector IO on that one. You know what? Let's change this to just import collision and then do collision dot. That way, in the code, it's very clear which one's using what. Okay, so that wants a vector and a radius. So that's going to be static circle vec, and then radius is static circle dot radius. So now we have geometry for our big circle. Let's get it for our small circle. Probably call this, like, well, I don't know if small circle is the best. Drivable circle? I don't know. Let's just leave it for now. Circle vec. Okay. Now we have 2 circles, and we should be able to call glide on them and get a response. No thanks. I feel like the Twitch moderation UI seems to change relatively regularly. I feel like, I guess it's a good thing in some ways that I don't have to ban people frequently enough that the UI has had a chance to change since the last time I banned somebody. But it would be nice if, like, each time I try to ban somebody, it worked mostly the same way. Like, it's changed on me a few times. Okay, so we're going to be able to get the shortest colliding int or float. You can pass in a response in order to reuse it. That's cool. If there is a collision, that response will be updated. If there is a collision, then the response will be updated. But if there's no collision, is it gonna just return the one you passed in? But I guess you would always call reset first. Okay. Not super clear, like none of these are the Boolean, right? So, yeah, I mean, these two are, but those cover the cases that I actually don't care about as much. If this is subtracted from the position, so is that like if it's positive or something? It's not super clear to me how you know if there was a collision. I guess let's just start calling it and printing it out. I think your overlap is only set if there's a collision. Oh, okay, so it'll be maybe none or something like that, or negative. Maybe that was one of the negative infinities or something. Yeah. So the ones that are in, I do get, and I think for those ones, I mostly don't care about them as much. Realistically, if I re-implement this, I will implement a Boolean that says, like, do you want to worry about those ones or not? Because from what I understand, those ones are a bit more taxing to calculate than just the edges, basically. All right, so I guess let's make a response and try to reuse it. So maybe collision response. I would assume I don't need to call this, but I would also assume it's like safe to, and better safe than sorry. So then we can go, so does it return itself? But you pass it in too, though. Oh. Okay. I'm up to speed now. It returns the Boolean. If you want any of the rest of that information, then you need to use the response object. Okay. And I don't really care about that stuff, at least for not for right now. So let's turn that back off. And then we can actually just structure it the same as this. If they collide, do the thing. Oh. Why is it not collision.collide though? What is trippy? Oh, TryPy. Response is a good object, is good if object A is moving fast, then maybe you want to use the vector to make sure it only touches B and isn't now partly inside of it. Oh, I gotcha. Make sure you don't overshoot. I don't see... Am I missing something? Let's look back at the example. You just say if collide, which they would have gotten from this. Oh, is that in tests? Did I kill it by taking... I did. Okay, tests are not like unit tests. Tests are like test for collision. Whoopsie daisies. We cannot just do this. So what was the problem with tests? Type error. Very, very non-specific type error. So at 13, we create a poly, given it vector 0, 0, vector 0, 0, vector 0, almost 0. This is looking for position, points, and angle. Wait, where's this square bracket go to? Okay, points. So we're actually, so we're passing position and points only. Position is a vector. Points is a vector. Is a list of 2 vectors currently. Angle is 0. This says self.dict angle angle. What is self.dict gonna do? I don't even know. I don't believe I've ever seen that. Used. Yeah, I would say I have this question as too. Almost all of the time you shouldn't use it. If you're accessing an attribute, the attribute name is known and fixed, then the only difference is the latter won't look up the attribute on a class if it's missing on the instance. Very rarely a reason to do this with the differences it illustrated below. Demonstrated, not illustrated. Class A contains attribute b equals 3, but it's not an instance because it's not inside of a init. So a dot b is equal to 3. A equals new a. Now we have an instance of a. A dot b, the instance doesn't have this attribute, so we fall back to the class 3. A dot dict b, the instance doesn't have this, but we don't fall back. Does anything ever, so there are lots of cases where we just access self.angle. So Polygon doesn't have a parent. Well, we don't care about the parent. Polygon doesn't have any class anything. Well, doesn't have any class attributes. Let's not get ahead of ourselves. It's got some things. It doesn't have any class attributes. And importantly, it doesn't have any angle class attribute. So if there is no class attribute, then the fallback case doesn't matter either. I would, let's say, guess. What if we just do this? Oh, I think there's a time.sleep at the beginning of this. Yeah. I put that in there because I was working in the core and I was scared of like hard locking it, basically. Function takes 2, but 0 were given. Okay, so that I think I just didn't finish writing the code, did I? Yeah, there we go. Okay. So we're getting close, I think, maybe, to at least like calling it and seeing if it works. So we can say static circle geo. I should call the other one circle geo. Oh, I did. Okay. Okay. It's not like horrendously slow even. Doesn't work either, but you know, could be worse. Oh, you know what? We're not updating the geos. So we're creating the geos when we create the circles, and then we're just continually testing if the geos intersect, and they never do because they weren't touching when they first were created, and we're not updating them, which is that thing about the geometry being separate from the vector IO. So when we go and change circle here, we actually need to be also updating circle geo dot position dot whatever we change. Does it matter if we are like y goes up as the further down you go, like we're flipped on the y-axis? I wonder if that's going to matter. Because I don't know if this geometry, I don't know if this collision library thing is expecting the axes to be a certain way. Hey. All right, it seems to work. And it actually is doing a good job on this like corner case here, so that we can tell that it is definitely actually doing like circle collision and not just cheating by using the bounding box. Because totally, if it was just doing the bounding box here, those would be counted as colliding. Shouldn't matter. Perspective is just that up, down, left, right. Doesn't matter. Okay. Oop. Yeah, that happens sometimes. I usually end up turning auto reload off because of that. We could probably shrink this a bit. I'm not really messing with the core anymore right now, so maybe we don't need this at all. I'm going to leave it as one just for extreme paranoia, I guess. What is the license of this? MIT. Okay. Well, I should look at that before I start messing with it, huh? If you're worried about performance, can you write a quick FPS counter? Yeah. It's true. And I am, I would say, ultimately worried about performance, but I think that this test, I'm not necessarily interested in testing it just yet. I want to get the rest of the types of collision, like Polygon. So circle, I actually had completed already a different way. So technically, I didn't break any new ground with this, although it is using that library that I just found, well, modified to work on CircuitPython. And I am ultimately, but the case where I'm actually more concerned about the performance is, I think, I don't know if I left it actually. Is this one running? Let's see. Okay, yeah, this doesn't have it running right now. The case I care about more so than this is when there are a bunch, like dozens of shapes, and you want to test one main shape against all the other shapes. And I will recreate that test and do it at some point and compare it to the core implementation of the intersection code too. But I do happen to know it's like fast enough pretty much for what I want to do, I think. So it may not matter too much, but it may be nice and give me the ability to push even farther the amount of shapes that are in play. So let's try this one. Actually, let's just get it to run first. I'll take the collision back off for now. Okay. So this time, static. So that wants a position. Hmm. I don't know. I don't think we have that point. Yeah. Okay. So this library wants the center of the polygon, but we don't know it. I don't know it. It calls it a circle here too, so it's copied probably the docs, but I mean for use with rectangle, we could calculate the center and use it because it's always like half the width, half the height, plus the xy, which we do have the xy. But for use with actual vector IO polygon, we don't know the center. We know what the vector IO doc said, the 0, 0 within the coordinates that the vector will exist, coordinate plane. I do also notice that it says the points can't be changed, which means the way the circle works, where we're updating it like this each time, and then being able to do the test afterwards, we would not be able to do with Polygon. And then since there's no rectangle, we would not be able to do it with rectangle either, since we need to be using Polygon for rectangle. We'd have to be creating a new object every time, which I don't like the idea of. Okay, well, this was interesting. I'm glad I tested it out. It's a good prior art to maybe take some inspiration from. It's cool that it does actually work. And if you were interested in this kind of information, this library would be super handy since it already seems to calculate all this stuff for you. In my case, I don't care nearly as much about any of this. I only care about, right now, this Boolean true or false. And so I think while I could use this for circle and rectangle, I think I'm gonna probably start heading a different direction because really Polygon is my main aim. I already have implementations that work with circle and rectangle. You know, if we could bring this in and it would also work with polygons, it would make sense maybe to use these ones. But I don't think it necessarily makes sense to use these to do the same thing as some different ones when this won't actually do the other part that I'm interested in. So I think that gets us back to here, which is we are going to need to go ahead and implement this is Polygon Circle. I think I started looking at Polygon Rect first. But both of them are going to use similar things. We're going to basically need to get line rect and line and then use them to create polyrect. Okay, so I will do that in Python code here in a minute. I do got to run to the restroom though, so I will be right back. Okay. So let's actually go back to the line page. I could just copy it from here, but it will be nice maybe to have the theory from this page. Check if two lines are touching. We have to calculate the distance to the point of intersection. Super sweet sword fighting game. Okay. Okay, so we have two lines which are defined as x1, y1 is the endpoint of one line, x2, y2 are the other endpoint of the same line, I presume, and then we have x3, y3 as the first endpoint of the other line, x4, y4, the fourth endpoint, which is the second endpoint of the second line. So basically, we're doing some division and subtraction of all the points, and then checking if our value was between 0 and 1. Which is actually close enough to Python code, it might just work for us. Let's get rid of this for now. Actually, let's keep that. Let's save it. Let's copy this out as collision lib test. And then with this one back in code, we're going to get rid of this. We're going to get rid of this. Get rid of all the collision stuff with that library. You got to take a hat. Some kind of ear covers. Okay. Okay, and then I'm gonna just make a thing in lib. I'm just gonna call it intersection for now. Def circle rect intersects. Well, I'm gonna do that one first though. We're doing Polygon rect intersects. But for this, we know that we want def line intersects x1, yes, but then also x3. We could take pairs. Should we do these in pairs, like tuples, or should we go and make an actual vector class like that other one did? Pretty much it has UA, which they're saying is the distance to the point of intersection. Okay, so we're kind of like taking the difference between the x's and the y's, multiplying them, minusing them from the opposite ones, and then dividing, doing the opposite on the other side as well here. Okay, can't say as though I visualize what that math is entirely all the way, but let's see. And then if there is a collision, then they'll both be in the range of 0 to 1. So we could go return UA greater than 0 and UA less than 1. Okay. Oh, just that. Why is this mad? Simplify? Does it want to do the... Yeah, show me what you mean. Okay, yeah, put the variable in the middle. Okay. I do like that syntax better, actually. Doesn't like the name. Variable in function should be lowercase. I'm gonna call it distance. I mean, distance to the intersection point is what it called it there. I don't know why they used A and B instead of X and Y for the names. Like, does A just map to X and B to Y as far as the distance from the intersection point? I'm not sure exactly what they mean all the way. So I think there's not a vector IO line, right? Yeah, there's Polygon. I'm pretty sure... Polygon has to be a closed shape. I don't think that it can be a line, and even if it can, I don't trust it to necessarily work correctly. It's not really meant to. One way that we can, so I mean, theoretically I could test this without drawing anything. But I am kind of, like, realistically, when it comes to geometry, I am very much a visual understander of geometry. So it will be a lot easier for me if I can see what is happening and tell if it is correct or not just by looking at it and knowing if it is correct or not. To that end, I will get this, and that should be everything we need, I think. Okay. I have display. Might not have ever actually got display, yeah. Hey, good job. Hey, good job again. Look at that. So that's gonna fill it with, I think, 0 by default. I'm gonna actually make this 4. I'm gonna make white by default, so then we can draw colored lines on top. This would actually be 4 now. I think there's draw line, destination bitmap, canvas. X1, Y1. Let's just start with easy. The diagonal down right, and then hey, wait, why does that say value? Hold on, what are we doing? Value. Oh, we're only drawing one line. Da 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 da. Yes, yes, yes. Value, we'll just do 1, I think. Yeah, let's just do 1. Canvas. Group show, yeah, okay. Okay, the white did not work, but it did draw that line down the middle there. It was a little hard to see because it's 1 pixel, but oh, I see. There we go. Okay. So let's do another one. 0. Like that. Line 19 index should be 0. Nice. Yeah, thank you. Okay, so then should I do not yet? Let's say import intersection print. Okay, let me actually go line 1 equals line 2 equals except for these are still here. Kind of that. Put line 1 on both of them. It's weird to do 1 and 2 instead of 0 and 1. So, can I just do this somehow? It's not really an easy way to test that, is there? It doesn't just work like that. Now it thinks that's x1. Okay. I don't know. There might be a more elegant way to write this part. I'm not sure. What it is, if so. Well, I did 2. Okay, I did it wrong. Line 1. Keep getting my single line confused with my intersection, where I think I'm taking 2 lines, but that's not what we're doing here. So line intersects. Got a bunch of it. Randomly stopped one short, which is interesting. This doesn't work because I can't just split a multi-line thing like that. Okay, so to make sure that it works, if we were to stop one of these short, oh, they still intersect though. Right. I think this is what I'm trying to do. Yeah. Okay. So they don't intersect there. And theoretically, we could get this all the way up to like half the display size. Those ones technically are true. And I would think if we -1 from here, it should no longer be true. Although we may need to +1 because of y. Need to +1 because of y, actually. Yeah. Now they're false. And it is very, 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 very close. Not necessarily very easy to tell down to the exact pixel. but that does show us the edge is right there. Because we get false with that, and we get true with this. Are there any other cases I should make sure to test? Let's try if they match on 0, 0. So let's say this one goes 0, 0 to maybe 50, 30. Should be true because they intersect on 0, 0. Yeah. But if it was 0, 1, then they would not, or 1, 0. Well, either one. Well, no, actually, not either one. This one would still intersect because it goes down. Okay. Okay, I think that's working. So line's going to get used by line rect. Let me make sure that's right before I actually just do it. Yeah. Line rect. Okay, so they're taking 2 points, and then 2 points for the line, and then 1 point for the rectangle X, Y, and 1 point for the rectangle width height. Okay, we'll just match that. I am tempted to call them line X1 and line X instead of just X1 and X2 and RX. Makes sense. Yeah. The line rectangle is basically just calling line, one for each side. This is not exactly Python, but it's close enough. Okay, well, it's sort of close enough. I don't know what's up with the new lines, but... I did call this different. Also, I called all these variables different. Yeah, maybe there was no point in copying it since I'd changed everything. My rename will try to rename it in the other one as well. What? Should have done x2 first, maybe. Oops. Oh no. Oh no, oh no. Actually, that was okay, but now I've undone it. Wasn't expecting quite as many. Alright, we don't need semicolons, and it will probably... Honestly, I think, let's not do it that way. Let's just take the line, split it right there after the line, so we get line arguments on one line of code, and rect arguments on the next line of code. Then this is basically, oops. Realistically, we could make this ever so slightly more efficient by returning early, right? Like, as soon as this is done, if left is true, we could just return true rather than doing all four and then checking all four. I think I'll leave it alone for now, but that's maybe something to do later if we want to make it slightly more efficient. So there's also, I think, a bitmap tools draw rect, which will be convenient. So let's turn off line 2. And then let's make rect, I'll just call it rect1. Gonna take x, y width height. So I'm drawing a line diagonal down the center. Let's start with well, let's start with the easiest thing, which is 0, 0. Whatever, let's just say 50-50. That'll definitely be intersecting, or it should. Don't necessarily need separate lines, although the next one probably will, because I'm going to do some display width and height math. Ooh, thought there was a draw. Oh, I think it's called fill rect, or fill region, yeah. Maybe, well, I don't know. Maybe it's not worth changing after the fact, but I think that one might be better to be draw instead of fill, since we have draw line, draw circle, draw poly. Okay. So we want to go line rect. That way again. Right, so intersect is true currently. And we can test a false case if we just move that over. So let's say, let me just leave that actually. Wait, X, Y. Width, height. Aiming for over here. Like I failed. Oh, this is not XY width height. This is XY. It's opposite corners. Basically point, so top left corner point and then bottom right corner point, which is actually different from XY width height. So the one question is, do I want to keep this as XY width height? I think I do, because really I'm kind of basing it on what this takes, although I could change this to match that. But the thing is, ultimately, Vector IO is more my target than bitmap tools, and in Vector IO, the rectangle does have an X, a Y, and a width and a height, not a XY1, XY2. So to calculate that, we would need to basically take the start point plus the width, take the start point Y plus the height. Okay. I did hit the place I was aiming for, which is nice, and it says intersects false, which is also nice. I think if we did it up to 100, it should intersect. Basically, we could go up to half the display height and width, and it would still it would intersect. So I believe that should be a true. Yeah. And then again, if we, let me keep that one. If we -1 there, and we, this time we actually -1 here as well, because it's height and not Y coordinate. And that one is now false. And again, it's very, very difficult to see in terms of the pixels. And in fact, the pixels are still, you know, two pixels next to each other could still both be turned on in the same color, and the intersection can be false because technically intersection is overlapping, not just touching. So there needs to be at least one pixel of overlap for intersect to be true. Okay, so line and line rect are both working. We can now use those to make polygon rect, which is basically a series of line rects. And then what I'd like to do, I think, is add the fully contained Boolean to say whether or not you want to worry about that. So to do this, we test each side. Okay, so this is taking place on every vertex, every point within the polygon. Doesn't show a for loop right here, but it needs one. Yeah. Okay, so for this, I am gonna ultimately switch us back to vector IO. I'm just gonna copy this again also. Intersection lib line and rect test. And in that case, I am gonna get rid of the bitmap canvas, and we're just gonna be going back to vector IO shapes. I mean, theoretically, we can test this on two rectangles, since a rectangle is a polygon. However, maybe I don't want to. Yeah, I think I don't want to do it that way, though. I want to do static polygon equals vector IO dot polygon. So that's looking for a pixel shader, and then a list of points, and then an XY. So let's just see if I understand how this even goes. So pixel shader, palette, what was it? Points? I guess the order doesn't matter. Points, tuple. So let's say 0, 0, 50, 0, go over, down, 50, 50, and then 0, 50. That should draw a 50 pixel square, basically. So those are our points. Then we had, what else? XY. So I think we're going to go 0, 0 on that. Why is this all mad? expected list tuple tuple tuple, but I gave it tuple tuple instead of list tuple. That's fair. Change it to a list. All right, let's see if that even draws. It did. Okay. It is on white. Let me change it to blue. Or whatever color this is. I think that's blue. Yeah, okay. And then let me see if I understand what this does. This will move it out from the corner, right? We'll make the top left corner be at 2020 instead of, yeah, okay. So it basically, this point on the display, this pixel coordinate on the display will align with 0, 0 inside the plane where this polygon's points are declared. And I have chosen to do it where 0, 0 is one of the points that I'm using. But that is an option. I believe you don't actually have to do that. I could do like -10 and we would make a weird squished looking thing, like a kite, I guess. But XY, that pixel coordinate on the display does still map to 0, 0, even though it's not actually one of the points specifically. So it's kind of like the anchor point, basically. Okay. So if you would agree to always center your polygon on 0, 0, we could actually theoretically use that other library, but you would have to agree, like the code, you know, within the code, you would have to always do it such that 0, 0 is the center, which is not currently a restriction on Vector.io. So I will, let's see here. Okay, let me do this. Let's actually go and center it for now. Oops. Okay. And we have a square in the center. Let's make our drivable square moving rect. And let's make it actually move, which is this chunk. But okay. We have no intersection logic now. Let me change this to 2, which is how that was before. Okay. So we've got a polygon. Whoops, we've got a polygon. Technically, it's a square. We'll increase the weirdness of the shape as we get to testing. But this will be a good one to test on to start with, is square against square, even though technically we're using the polygon algorithm. And we're basically testing each vertice, each line that makes up the polygon. Which they have convenient access to vertices, but we don't necessarily. So this one is actually, we're going to end up differing a little bit. Because I think I'm in favor of not passing in the vertices, but rather passing in the points, the vertexes. And then the code inside of here is going to need to go through those vertexes, those points, and use them. So that is the polygon points. And then we're going to have the rect x, rect y, rect width, rect height. So first things first, we need to loop through the points and actually get the lines from them. So I'm thinking we go... Do we need to do +1? So in this case, we are starting on 0. So we would say the first line is the first point going to the next point. I'm actually going to go and make this even easier and say cur point is that, next point equals polygon points plus I, but... Dude, I'm not sure if we need this. I'm going to take it out until I can see what it prints. We're going to do this +1, but we're also going to go... Yeah, exactly. Whoa, okay. Modulus, that way it will wrap around. So that would be, so in our square, we have 4 points. So we're going to be going, I is range 4, so 0 through 3. So we're going to get 0 and 1, 1 and 2, 2 and 3, 3 and 4. 4 will wrap back around and be 0. That sounds right in my head. Cur point, comma, next point. Static polygon dot points, and then moving rect x, y width height. Maybe I shouldn't be calling this in the loop already, though, because that's just going to spam a lot. I do not have any idea what would be trying to use less than. So I guess I'll try this. Why is anything calling less than? Uh, I don't get the less than. Also, it seems like it's... Hold on. Am I returning? I'm returning false. Moving rect yet? Okay, so 53 calls Polygon rect intersects. Then this says at line 7, which is when we try to print. We raised an exception, but if I take the print out, then now we raise the same exception at line 4. Am I like not allowed to use polygon.points? Maybe that's not a thing I'm allowed to do? No, that's fine. And it's a list of tuples, which is what I was expecting, I think. I am very, very confused. Even that says line 4 unsupported types. Ah. It's the same problem that I fixed a minute ago in a different place. I gotta remember that. Less than int list means I didn't call length. This means you were supposed to call length and you didn't. Unsupported types, lt int list. The real problem is you did not call length and you should have. Less than int list needs to call length. You need to call length. Okay. Now we can slowly undo all of this, turning everything off. I almost wish that would be like a type error. Like, why is that? I mean, was it a type error? I guess it is a type error, but yeah, I guess I don't understand exactly what it's doing under the hood, but I wish the wording on this would say expected int got list or expected int got iterable. Something like that would make it way, way more clear what the real problem is. All right, do we get lines now? We get lines. Okay, sweet. So we go over, we go down, we go left, and then we go back up to the beginning. Nice. Okay. We got every line successfully. We basically need to check each line and decide whether it collides, intersects with the rectangle. So we're basically going to say if line rect intersect, the line is cur point 0, cur point 1, next point 0, next point 1, and then rect. That's wrong. return true. So this one is actually doing the more efficient route of returning early. Division by 0 error. Made it all the way back down into line. Huh. Wonder if we're not allowed to use negatives. Well, dang. Yeah, it failed on the first one. All right. I think that's about all the geometry I got in my brain for the moment. We don't really make it to a successful implementation, but I feel like it's fairly close. I don't know if this is just a bug in like one of these maybe, or possibly just an edge case that we need to test for. Or another option is maybe I'm not allowed to actually use those negatives. Maybe those need to actually all be positives. Well, actually, hold the phone because actually we need to offset each point. Hello, my friend over on YouTube. My apologies, I'm not certain how to pronounce your handle there. I am about to wrap it up fairly quick, though, so I will say if you got a question or comment or anything that you'd like me to see, definitely drop that in the chat fairly quick. These points are wrong, actually, though, right? These points are in the polygon's defined coordinate plane, which, again, is that one where XY display maps to 0, 0 in that coordinate plane. We're not accounting for that in this right now. We're just taking those points plain. We actually need to be... We would actually need to be adding the... We need more stuff, actually. We need another argument at least, because... Yeah, we need another argument because these points are in that coordinate plane that we define them in, whereas our rectangle is in our display coordinate plane, which are different. So we need to not be just taking these points how they are. We actually need to be shifting them by the XY of the polygon, so that we're basically moving that polygon into the display coordinate plane, which is the one we care about in this case. Need to shift these points by polygon.x and polygon.y in order to move it into the display coordinate plane. Need to add another argument or two for polygon X and Y. Okay, I am going to head out for now. Thank you to everyone for hanging out here in the chat and watching along. Thanks for the folks that helped out as well. Appreciate all of you. Hope you all have a good rest of your weekend, and I will be back next time at the usual, next week rather, at the usual time, 10 a.m. Central Time on Saturday. Until then, I'll bid you farewell. So long. Thanks for tuning in. See you later.